I am again here to help you to conceptualize one-tailed and two-tailed tests in testing hypothesis about the difference between two groups. You may recall the last session with me when we discussed about the concept of degree of freedom and errors in testing hypothesis. We could realize how degree of freedom helps in eliminating errors and normalizing the data for using inferential statistics. That day, my both students came together to discuss with me about the statistical technique they could use to analyze the data they obtained for their dissertation research work. I asked them about the research design of their research. I found that both of them wanted to have answer of the same question, but by doing their own research separately. The research question was, does the use of a smart board in teaching influence the level of creativity of elementary level students? Hearing it, I looked at them with surprise and asked inquisitively that both of them were supposed to conduct their research independently for the purpose of their dissertation work, and they were working on the same project. Both of them first smiled and then one of them answered that though their research problem was the same, but they had formulated their null hypothesis differently, and thus they had designed their research accordingly. I again questioned them how. The student, whose name was Anjali, told me that she will take up two intact different groups by using randomized cluster sampling technique. One she will use as control group and the other as an experimental group. Then she will teach the same topic to the control group in normal situations without using a smart board, and to the experimental group she will teach the same topic by using a smart board. After completion of the treatment, she will test the level of creativity of both the groups by using some standardized tool of measuring creativity, and thus the collected data on both the groups shall be analyzed to get their means for both the groups. I was happy to learn that Anjali had prepared a good research design. Then I turned my face towards Pooja to know what she had planned for her research. I found that she was also eager to tell about her research design. She told that contrary to Anjali's plan, she will continue her study only up to one group of students. She will first select a group of students randomly, then she will apply the same test of creativity which Anjali will also use on those students before teaching. After obtaining data before the treatment, she will also teach the same unit to her group of students by using a smart board. On the completion of the treatment, she will again apply the same test on those students to get post-treatment data. She told that she will also compute means for both the sets of data she obtained. It was a bonus to me as a teacher. Both the researchers designed very aptly and could yield the results to answer their question. That is, does the use of smartboard in teaching influence the level of creativity of elementary level students? I question them further. Then, how they shall establish the significance of the difference between two means? They will be obtaining by using different research designs. They bounce that question on me by saying that they came to me only to get the answer of this question. Of course, it is very important for a researcher to understand that how these designs will yield the results. What kind of difference may be there in giving treatment to the obtained data? How these two studies shall give a statement about the use of smartboard in terms of level of creativity and so on. Let us see these two cases appearing on the continuum of normal data, that is on the normal probability curve. You may see these two curves in figure A for Anjali's research and in figure B for Pooja's study. Now, let us discuss the case of Anjali, where she used two separate groups and got data for two independent groups. Look at the figure A, in which you may find two curves drawn separately for both the independent groups. For control group, figure 1, and for experimental group, figure 2. If we place the curve of experimental group on the curve of control group, it may go both way, as you may see in figure C and figure D. In figure C, the mean value of experimental group is higher than the mean value of the control group. But in figure D, you may find that the curve of experimental group is shifted towards the lower side of the control group. This shows that the mean of the experimental group may fall at any side of the normal distribution curve, meaning thereby, in this case, both the sides of a normal probability curve are affected and both the tails of NPC are used. In Anjali's case, she formulated her alternate hypothesis as non-directional hypothesis. In case of non-directional hypothesis, both the tails of normal probability curve remain influenced. When two-tailed test results, it is possible to detect a difference between true value and the hypothesized value of the parameter, regardless of the direction of the difference. Anjali had hypothesized that the use of a smartboard in teaching influences the level of creativity of elementary level students. It is a non-directional alternate hypothesis, which Anjali had converted into null hypothesis for testing as that the use of a smartboard in teaching does not influence the level of creativity of elementary level students. Such hypotheses are tested with the help of two-tailed tests of significance. In most cases in which the performance of a group is compared with a known standard, it would be of interest to us to discover that the group is superior or to discover that the group is inferior. If we analyze Pooja's case, where she sets a standard for her group of students before applying the intervention program to study that's influence, and then she wants to discover whether the results obtained after the intervention program shall be superior to the set standard performance of those students or shall be inferior. If we analyze Pooja's case, where she obtained two sets of data by using pre-test and post-test design of research on the same group of students, we may see the direction if we compare the results obtained on these two sets of data. If we plot the data on a curve, we may find that the results shall either shift to the positive side of the curve or they will lean towards its negative side. In her case, the hypothesis Pooja formulated was to see whether use of a smart board during teaching enhances the level of creativity or not. She wanted to explore whether the results shall increase or shall decrease. We can see direction in this hypothesis, and thus it is a directional alternate hypothesis. You may see on the screen how set of scores obtained before and after the intervention program and how the direction of test is reflected on the normal probability curve. It is either on the positive side of NPC or on its negative side. In other words, the difference between two means shall appear only on one side of normal probability curve and only one tail of normal probability curve shall be affected. Therefore, this is termed as one tail test of significance by which directional null hypotheses are tested. In directional or one tail tests, the alternative hypothesis limits what a researcher has a choice to discover. If alternative hypothesis says that the population mean is more than the value of mean obtained on the data, then the only thing a researcher can find in this study is that the mean is more than that of the mean obtained on the data. A value of population mean that falls below the mean value of the data cannot lead to rejection of null hypothesis, no matter how deviant it may be. The major disadvantage of one tail test is that it does not allow for any chance of exploring that reality is just the opposite of what the alternate hypothesis says. In Pooja's case, it would not be discovered if the use of a smart board in teaching hampers the creativity of students. You may ask me, then why do we use one tail test if it limits the chances of exploration? Yes, you are right in most of the cases, but there are several situations where we want to discover only specific direction. For example, does use of a smart board in teaching hamper learners' creativity? So that the smart board may be used in teaching without bothering about the level of creativity. In such situation, the use of directional alternate hypothesis shall serve the purpose very well. Now, let us talk about the difference between one-tailed and two-tailed tests in terms of their statistical application. If we observe that how the results of one-tailed test and the two-tailed test appear on the normal probability curve, we may find the difference in the value of Z score on the same level of significance. Just to note that the value of Z scores at 0.05 level of significance for one-tailed test is 1.63. At the same time, for the two-tailed test, it is 1.96. In case of two-tailed test cases, where both the tails of NPC are considered, the area for 5% of cases is divided into two and placed on both the tails equally, that is 2.5% at one and 2.5% on the other. Contrary to this, in one-tailed test situation, only one tail of NPC is taken into consideration. Therefore, the 5% of marginal cases are kept on one end of the normal probability curve at one time. Therefore, for the 5% level of significance, in this case, the Z scores are calculated for 5% cases at both the tails, thus for 10% in total. In the same way, you may see in the table given on the screen that for the 1% level of significance, the values of Z scores obtained are accordingly in both the cases. For two-tailed tests, the value of Z scores for 5% level is 1.96 and for 1% level it is 2.58. At the same time, the value of Z scores in case of one-tailed test is calculated by using 10% and 2% cases. I found that with this discussion, Anjali and Pooja got an insight into the significance and the use of one-tailed and two-tailed tests for testing their hypothesis. They questioned me further that only understanding the concept of one-tailed test and two-tailed test does not complete their work. They wanted to know that whether the value of difference between two means they obtained separately on the basis of the data they obtained was significant or not. To them, I further explained that for establishing significance of difference between two means, we may calculate critical ratio of the value of significance of difference between two means by using t-test. At the same time, I also told them that the t-test is a parametric test and may only be used when the data is on interval scale, randomization was done, and when the data is normal in nature. That is, the data forms normal probability curve. In case the data does not fulfill these qualities, parametric statistics may not be used for drawing inferences. My students immediately questioned that in case these conditions are not fulfilled, how a researcher shall draw inferences on the basis of the results drawn on that sample. Restricting myself to the main track, I simply told them that there are some non-parametric statistics as well, which may be used in the cases where such conditions are not fulfilled. That time I instructed them to stick to their studies only, as both of them were fulfilling the criteria for parametric test. They further asked me whether the same procedure will be used to obtain the critical ratio in their both cases. I told them that the concept of deriving critical ratio in both the cases is the same. The critical ratio in any case, when we aim to calculate significance of difference between two means, may be computed by comparing the value of difference between two means with the value of the standard error of difference between two means. It is actually the process of obtaining critical scores for that amount of difference in order to compare it with the place of standard scores lying on the continuum of normal distribution curve, and then to discover whether the critical value is falling in the area of rejection, as you may also see on the screen, that is the value of the difference between two means divided by the value of standard error of difference between two means. It may be written as has been shown in the figure. My students immediately questioned me, then how t value is different from z scores when both are placed on the continuum of normal distribution in terms of standard scores. As we know that the z scores represent the value of a normal distribution, and when we calculate z scores, recall the procedure we used in our previous session. We divided the value of the difference between the means of the population and the value of a normally distribution variable by the value of population standard deviation. In this case, the value of population mean and population standard deviation remains constant, and therefore, in all variations the nature of the data remains normal. In other words, it may be said that z scores represent the normal data. On the other hand, when we do not know the value of population standard deviation, then we use the value of standard error of that statistics in place of population standard deviation. Contrary to population standard deviation, the standard error of that statistics from one random sample to another random sample. Hence, thus calculated critical value may not be considered as z score. Rather, this value is termed as t value or t ratio, which states about the position of that variable on the continuum of the distribution. In case of z score, the constant value is divided by a constant value, therefore resulting into a constant value. Whereas, in case of t values, we may see that the constant value is divided by the variable value, which yields variable score. Thus, t value refers to the case. Both of them were taking interest and were very happy to learn it that both of them compute the critical ratio together by using the similar course of procedure. Making them well aware of the case, I mentioned to make them realize the point where the difference lies in the procedure of the researching to the value of critical ratio. I explained that of course, the formula we use to calculate the critical ratio in all cases remains the same. At the same time, the procedure of obtaining the value of standard score of difference between two means is different in both the cases. Anjali and Pooja both had the question, why I had to answer. I explain. In case of Anjali, both the groups were not correlated and were independent from each other. The students or the cases were not related to each other. The data on both the groups was independent and hence means on both the groups were also independent. Contrary to this, the two sets of scores in case of Pooja were obtained on the same group. The data of one set had an influence on the other set of data and vice versa. Both the set of scores were correlated and dependent on each other. For example, if the student on third place has secured good marks in first set of data, he shall also secure higher place in the other set of data in the same ratio. Some amount of correlation always exists between these kinds of sets of data. Therefore, while computing standard error of difference between two means, for such cases, the effect of correlation between two means is to be given due importance as it affects the value of difference between two means. In this way, the conceptualization procedure for computing the standard error of the difference between two means is different for one-tailed and two-tailed tests. Let us start with the computation of the standard error of difference between two means which are uncorrelated or independent and have been drawn from two different groups. Let us recall the procedure of computing the standard error of mean which was calculated in our previous session while we were dealing with the reliability of mean. The standard error of mean was calculated on dividing the standard deviation of the population by the square root of the size of the sample. You may see on the screen how does it happen. Suppose the standard error of that mean is standard error of mean 1 and that of the second group is standard error of mean 2. If we want to find out the standard error of the difference between two means, we may compute it by adding the standard errors of the means. Let us see on the screen. How do we calculate the standard error of difference between two means? That I shall take in the next session. Now, you may study the cases where one-tailed test can be applied and where the two-tailed test can be applied. It shall help you to get an insight of using inferential statistics for your research. By that time, my best wishes, we shall continue this deliberation and the procedure of computing standard error of difference between two means in our next session. Best wishes once again.